So now that we know what the equation for brightness is and what all of these letters mean, we can put this equation into code form down here and put it back into our coding activity app in this other page. So what I'm going to do is first copy this to clipboard. And before I paste it, I just want to talk a little bit about what this little fragment of code is doing. So what we're doing is setting luminosity equal to 1, which means that we're just making that the luminosity of the sun. So we're just saying the sun has a luminosity of 1, and we're going to make all our stars that we now generate have an energy per second, or luminosity equal to that of the sun. Then in the second line of code, where we have brightness, we have this factor that says 1 million. Now this factor is just there so that we can compare the different brightnesses that we generate easier later on in the Excel sheet. So don't worry too much about that factor. What's important is that we're writing in the equation, so luminosity, which is the numerator right here, divided by 4 times 3.141, which is pi. And we have z times z, which is equal to our distance squared. We just have z, we just called our distance z in the code. And we're going to draw it. So at the last line, we have draw and our x position, our y position, and our brightness. So again, I'm going to copy it to the clipboard. And I am going to
go ahead and
remove
part.
This part.
Yep.
And I'm going to Control V and paste that. So now keep in mind what our previous image looked like. So here we just had a bunch of bright stars. And in the image before that, we had a bunch of dim stars. So let's see what this new code does. I'm going to click play.
That's kind of fun.
Yeah. It's now making stars that are a bit brighter. Like this one is brighter definitely than, I don't know, there's a few up here that are much dimmer.
Yeah, some you probably can't even see. It's really close.
Mm-hmm.
So what we're doing now is that before we were assuming all the stars are the same brightness on the sky, and it looked really lame. Right?
Mm-hmm.
I don't know if kids still say lame. I don't know. I say lame.
I still say lame.
Lame? Okay, good. So now instead of having all the stars have the same brightness, instead we have all the stars with the same luminosity.
Mm-hmm.
Okay? So they're all emitting the same energy per second, but some of them are closer and some of them are further away. So, for example, these ones that are brighter over here, those ones are very close to us, right?
Mm-hmm.
And so z is very small, and so anything divided by something small becomes something big, right?
Correct.
And so if z is very close to us, is very small, then it's going to be nice and bright. But if z is far away, if this is 20, then 20 squared, that's a pretty big number.
That's a pretty big number, yeah.
Yeah, compared to like 2
2.
squared.
Mm-hmm.
2 squared is 4.
4. 20 squared is 400.
400. So that's a pretty big difference. So as a result, I feel like it's a little bit more realistic than it was.
It is a little more realistic. I like it a lot. But all the stars that we see in our night sky are not the same luminosity as our sun.
Nope.
So we have to take it one step further and see how we can make it more realistic, not just have a bunch of suns in our sky at different distances.